In this lesson, we provide example of CryptoAnalysis on a simple crypto system, the Monoalphabetic Substitution Cipher. Besides simple brute force attack on guessing all possible keys, sometimes with additional knowledge and information about the crypto system and the encoding scenario, it may be easier to decrypt the ciphertext. There are three variations of cryptoanalysis or ciphertext. Number one, ciphertext only case. Sometimes cryptoanalysis has some ciphertext, but they may not have the corresponding plaintext. Typically they not knowing the key, they do not have the encryption or the decryption function. Second case, non-plaintext case. The cryptoanalysis knows some matched a pair of ciphertext and the plaintext. They might discover through some communication or channel, but still they do not have the key. They may or may not know the encryption and decryption function. Third case, chosen plaintext case. Here we have the ability to encrypt piece of the plaintext of his own chosen. Know the encryption or the decryption functions, but typically we don't know the keys used. Here we try to illustrate the cipher attack on monoalphabetic substitution cipher, and use it as an example to illustrate the cryptoanalysis process. In monoalphabetic substitution cipher, we map each character in plaintext to a unique character in the ciphertext. We often represent the plaintext with lowercase letters and the ciphertext with the uppercase letters. The understanding of the encryption and decryption function for this cipher qualify its cryptoanalysis as the variation of chosen plaintext case, as classified in the previous slide. Even though we do not know the exact mapping function, we also know that most of natural language has statistic property based on their alphabetics. For example, in English, the frequency of single letters or called unigrams based on statistic analysis of vast literature show the following characters appear most often. They are E followed by T followed by O, A, N, I. Thus, E show up most frequent in most articles. The top appearance of two letters, or we call diagram, are TH, IN, ER, RE, AN. Same for the trigram, which is three-letter combination, THE, ING, and ION. Armed with these knowledges, we can now proceed with the cryptoanalysis with the following four steps. Step one, generate and rank the unigram, diagram, trigram, quadgrams in ciphertext. We can find a lot of tools in the internet to use to generate these statistics. Step two, let's look at the trigram and quadgram of the ciphertext and try to map them, because each of them can map three single character mapping or four character mapping. For example, if we find the following top mappings in the ciphertext, for example, uppercase F and S mapped to the lowercase, the plaintext THE, F and SY mapped to THER, uppercase PTA map in the ciphertext mapped to the plaintext AND, which appear second most frequent, NSYS in the ciphertext mapped to the plaintext HERE. And here we using this mapping, we use uppercase for denoting the ciphertext, lowercases for the plaintext. From the first couple words, we find F in ciphertext is mapped to plaintext alphabet T, N mapped to H, S mapped to E, Y mapped to R. We actually can confirm them using the rest of the three mapping. This is called cross-checking. Step 3, cross-check and verify this mapping among themselves. And also we can use the diagram statistic and unigram statistic to confirm indeed they are the top frequency. Step 4, substitute this mapping in ciphertext. Identify further mapping using the word meaning we guess, we translate, and the word boundary. Iterate through this process until we decrypt the whole ciphertext. Let's now apply the 4 steps of cryptoanalysis on the ciphertext of a 4 stanza of a famous poem here. Step 1, we copy the ciphertext into a text box of a tool created by Padua on this URL, http://net.myuccs.com mtawa/sta.php. The result here we show the statistics result generated by that sta.php tool. We map the top trigrams and quadrants in this ciphertext and map them into the typical top one in the literature shown on previous slides. We choose the following 7 mapping. First, FNS mapped to THE, FNSY mapped to THER, PTA mapped to AND in plaintext, and SYS mapped to here, FNP mapped to THA, FNPF mapped to the known plaintext THAT. We see the first 3 mapping can be confirmed by the other 3 and those of unigram and diagram statistics. We try then to get as many mapping as possible as a strategies, and the result is the following mapping. F mapped to T, N to H, S to E, Y to R, P to A, T to N, and A to D. Armed with that character mapping, we now can proceed with the step 4. Given the mapping we get from the previous step, we use another tool which I create monosub.pl to substitute the known mapping to the ciphertext. First, we create a mapping file, map1.txt, with each line represent 1 character mapping. Then we run the command. It will then show the result in text preceded with the new line. Some of them are mapping with lowercase, some of them still maintain ciphertext undecrypted yet. By parsing the potential words in the last sentence, we got to where it lands in the undergrowth, where L, length, uppercase L, we haven't decrypted yet. With that understanding, we now have a new mapping H map to O, X map to W, O map to I, V map to U, K in plaintext map to plaintext G. This leads us to parsing the first sentence as two roads diverge in a yellow wood. We yield additional mapping of U map to plaintext S, B in ciphertext map to V, K map to G, J map to Y, ciphertext alphabet G map to IL. Now let's apply new mapping to the ciphertext in new iterations using the command monosub.pl scip.text map2.txt print2.txt, and the result output y is output.txt. By separating the additional words, we get fourth line, fourth word, uppercase E, O-U-L-D, and we guess it should be could. In this yield, uppercase E map to lowercase c plaintext. Fourth line, last word, uppercase L-O-T-H, should be both based on the semantic of the sentence. Therefore, uppercase L in ciphertext is mapped to lowercase plaintext B. Eighth line, second word, is L-O-O, uppercase D, E-D. It should be look. Therefore, uppercase D should be translated into lowercase k. Eighth line, sixth word, uppercase C, A-R should be far, lowercase f, A-R. Therefore, uppercase C in ciphertext should be mapped to lowercase f. Adding all this into the mapping, we were able to transfer almost all the points. By entering the first sentence in the Google search, we easily find the point was identified as the road not taken, one of the famous points written by Robert Frost, 1916. It is very challenging exercise like puzzle solving, but we have a lot of fun doing this. Here we learn how to use these additional knowledges in the English language to break this ciphertext as a chosen text case of cryptanalysis.